let the graph of G be a horizontal shrink with a factor of 1/6, followed by translation 3 units to the graph of f of x equals cube root 2x. So we have to write a rule for G. So again, we're reviewing things we've learned before. This is just with a different function that we haven't done it with before. So factor of 1/6. What do we know about horizontal?
It's inside.
Inside. And
it's the opposite, so you'll write like 6x.
Implicit operation, which I'm going to tell you and going to start using this word more, which is called the inverse.
So like how you turn this to 1.
Right. So instead of divide by 6, those are inverse operations. That's what 1/6 is, by the way. That's dividing by 6. Over 6 to multiply. But they're inverse operations. So we're going to start with like h of x. And h of x, we have to take our f of x function and we have to replace x with 6x. Yes, honey. I know. I know. See how that's okay. I have it here. Somebody already told me, but I have it here so that we can see the answer. I can show you the answer, but like getting there is the part that you have to be able to do. So remember when we replace horizontal things, we replace the x with that 6x. So in the f of x function, I'm going to have cube root 2, and then we replace the x with a parenthesis. And in that parenthesis, we write 6x. So there. So we're going to simplify that, and I'm going to have cube root my halfway through function, my h of x. Now it says g answer, so now I'll start g of x. And it says we're going to do a translation 3 units to the left. So again, we've got horizontal. It's got to be on the end. And it has to be opposite operation, or the inverse of subtracting, which is adding. Yeah, adding. So I'm going to take my h function, and instead of x, I'm going to replace it with x plus 3. So wherever I see a x in my h function here, I'm going to make it into an x plus 3. So we have cube root, we have a 12th, and then we have an x. So wherever I see the x, I replace it with x plus 3. Yeah. Okay, so now we have g of x equals 12 x plus, or idea what this is. Oh, maybe I could look at my notes from last year. I wonder if this is like a second example for the same, because it says f of x, it doesn't say g of x. So this is the answer for example 4. I wonder if this is like another example by sticking it there. It's kind of what it looks like, but
wouldn't it be a cube root instead of a square root?
Yeah.
And wait, is there square root, cube root of this or no?
And so for
no.
when it's inside, like for the quadratics, it still be the same. It's equals like, you know what I'm saying, like in the negatives, the plus sign, but equals like
If it's on the inside.
like in the negatives.
It always Yep.
It's a minus, it's positive. It's the same thing for cube root.
Totally.
A lot of things easy.
Yeah, and we've been doing it for a while too.
It's
It's just been a while since we did it last. Rachel? It's not.
Where did you get the 36?
I distributed 12 times 3. Yeah. Okay, so let's do the exact same thing just with a different function. Exact same thing, different. I don't even think this function is helpful. Nah, let's just skip this. I don't remember what I wanted that for. Okay. We'll do this together. Let the graph of G be a horizontal curve of 3, followed by translation 6 units to the right of the graph. And then this is our f of x, cube root x plus 3. And so we'll start with our h of x, which is our halfway through. That says to take f of x, what now? Horizontal stretch by a factor of 3. What does that mean I put in?
You put 1/3.
1/3 x. In this f equation, wherever I see an x, which is only one place, I'm going to replace x with 1/3 cube root, parenthesis 1/3 x plus 3. Not really anything to try other than get rid of the parenthesis, which I ended up not needing. The next part says 6 units to the right. So our g of x is going to say take our h of x, replace x with something that makes it go 6 units to the right. 6, right? Correct. I mean, so in this last, that becomes parenthesis x minus 6. So I'll have cube root 1 x minus 6, close parenthesis plus 3. So we're right. Now we can simplify that. So I'm going to take that, distribute the 1/3 into the parenthesis. I have 1/3 x plus. And then we can add 1/3. Questions before we try another? Nope. I did not I distributed right here. So I only distributed it to the x and the 6, but the 3 just came down.
Yeah, I
You were looking at the last step, right?
yeah, I kind of that. I see. I got that.
Okay. So last one, let
Good question, I guess. When you do the recommendations, is there a way to go back and see what the recommendations were?
not that I know
That's so stupid. I'm just curious.
of. Bye, Miss Gorley. All right. Let the graph of G be a vertical stretch by a factor of 2. Got cube root x minus 2. Write a rule for G. First part, h of x is my halfway through. We're going to take our f of x, and this time function or out. Okay, so I actually am going to start with 2, and then I'm going to multiply f of x by that 2. See how I put it on the outside with those wonderful brackets? See how I put it on the outside? Because that's where vertical goes, outside. 2 bracket cube root x minus 2.
is it? Why does all they be
So, matrix.
Which one are you talking about over here? This is different?
Yeah, and the one before is the
Yeah.
ours doesn't have the +3 and that, and ours doesn't have the -2.
So I must have changed it. Changed the file, or maybe I didn't update the newest file. And I'm
It's the same. I'm just saying, like, you don't got plus.
right. So the reason why I'm adding things on here is because the book used really, really easy ones, and then you go do your homework, and they're like really hard compared to the original ones. What I did is I gave you what was, because if it was only to the cube root of x, that's really easy. This other stuff, I just didn't realize the one that I gave you guys wasn't updated. So
I'm just saying.
no, it's helpful for you to tell me that, so now I can fix it. Cube root of x minus 2 is what I'm doing. Cube root of x minus. So we're going to do 2 times the f function, which is 2 times cube root of x minus 2. So now, with this 2, what should I do?
Distributed.
We should. Outside brackets. So I get 2 cube root x minus 4. These are the things that you guys in the first. These are the things you'd forget about. We're doing a stretch and there's more than one term here, we have to distribute it.
Wait, you don't distribute you don't distribute into the x, right? What?
Well, we can't take a 2 that's not a radical
Okay.
and put it under a radical. It just
Okay.
goes right in front.
Okay.
So now my G, add on the rest of it, which is translate 3 units up. So if I'm doing 3 units up, I'm doing x. If I'm doing 3 units up, is that inside or outside?
Outside.
So then I'm going to have brackets around my h of x, and then I'm going to put plus 3 on the outside. Cube root x minus 4, and then I'm going to have plus 3 on the outside of that. So 2 minus 1.
Did you distribute? So you moved back brackets and then added.
Yeah, because there was nothing outside of this multiplying. There was nothing. There wasn't a subtraction. Or I put them there so you to the outside of the function, but we don't really. It doesn't change anything. And then once you get through this part of the notes, the last part of our notes today are used. We are going to graph graphed by hand. You haven't done these by hand. They're not going to look like the ones we've done.
What equation do you have to use for circles?
It's on the next page. So it says use the graphing calculator to graph 1 squared equals x. Okay? And then it says identify the vertex and the direction the parabola opens. So let's review how we use our graphing calculator to graph. If we're graphing, on our graphing calculator, where right. So all of the buttons at the top, all those whatever whitish on mine, those are all the graphing buttons. So I'm going to go to y equals, and we notice that every single line says y1, y2. It all says y equals because it's the y equals button. Does what's wrong? Nothing? Oh, okay. I thought you were like trying to get. Do you have an error while we're doing this? Stop me immediately. I can't see what immediately, so I can go to the calculator real fast. You don't get really far behind. Yeah, it's easy. Here's the thing. This does not say y equals. And in order to graph it, it has to say by hand.
Multiply 2 to both sides?
We're going to make it say y equals, and that's where we're going to start. So we need to take this equation and first change it so it says y equals. Martin already gave it away. We're going to multiply 2 of multiply by half. That way we get y squared equals 2x. What do we do next? Root sides. There should be something dinging right now. It's in your head. Ding, 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 ding. Remember something? No? I better say it again. I'm going to square root both sides. What happens when I square root both sides? Chris? Can you guys hear what Chris is saying?
Yeah.
2 into y equals. Plus minus, and I can't take the square root of x. They're not perfect squares. No, because it's the square root of x to the first, which is also, we don't need this, but I'm explaining to you, it's also 2x to the 1 half. So x is to the first power. That's not going to get rid of any, it won't get rid of it. So this is what we have. And it really matters if it's simplified for graphing. Simplified. As long as y gets by itself, it doesn't matter if it's simplified for graphing. All right, how do we type in minus?
Now? Oh, no.
You can't.
Oh, okay.
Is you have to have 1 square root 2x and y2 negative square root 2x.
Okay, let me do that since I don't have my calculator.
Well, everybody should be writing this down, regardless if you have your calculator or not. On a quiz or a test, I would do what equations do you type in your calculator? So you would answer y1 is this, y2 is that. And really doesn't matter. Y2 could be the first one. And you could flip-flop them. So y1 is square root 2x. And then y2 is negative square root, oops, 2x. And then when you have that, you can hit graph. If your graph is not like centered, if it's really far zoomed out, if you're messed up, zoom 6, good job, fixes your window. So what I have is I have a square root that is positive, and I have a square root that is negative. I have a positive square root and a negative square root. Together they make a parabola. Remember we did square root graphing last class? The negative square root. But together they make a parabola that opens which direction?
Sideways.
Which direction is that way? To the right. So it asks us which direction it opens. So it opens
It opened up.
right. And then it also asks us to find the vertex. And this one, if you look carefully, yeah, it's at 0, 0.
Wait, how do you find the vertex again?
Well, you won't be able to find the vertex because it's two different equations. Like your calculator doesn't know equation. Remember, your calculator is not a thinking, breathing being. It just does whatever you tell it. So your calculator thinks you wanted two separate equations. It doesn't know it's really a parabola. Okay? So the vertex is at 0, 0. It's that one point in the middle of the parabola that has no mirror points. All right, what's next? Graphing a circle. So the equation of circle would be, actually there's more complicated versions of this, but very, very generic would be x squared plus y squared equals r squared. That'd be like the parent function, x squared plus y squared equals r squared.
But simply it's just r squared.
What, hun?
But just simply it's just r squared.
R squared?
Wait, instead of just saying it's just, I mean, x squared plus y squared, you can just simply say r squared and that's it.
Both sides of the equation.
What is you talking about, more?
I think equivalent in both sides of an equation. Does anybody know what R stands for?
Radius. Yeah, radius squared is
2 times the radius's diameter. Okay, so R is radius. Here we've got x squared plus y squared equals 16. Look, it says identify the radius and intercepts. Can we identify the radius before even graphing it?
Yes.
What is it? It is not 16. So R, hold on a second, R is the radius, so R squared is 16. So we do have to square root it to know that the radius is 4. Why is it not plus or minus 4?
Because it's,
Oh, we are square rooting. But why is the radius not plus or minus 4? If I do the square root of 16,
because it's a perfect square.
we're talking about a circle. We're talking about a radius, which is a length in the circle. Like, negative is a direct go. Negative is how long something is. So the radius is just 4 units long. That says nothing about which direction it goes. What?
So, when we find the square root of 16, do we do that to both, like, to the square root
No.
of both sides? Okay.
That's just to write down the radius. But we to on our calculator and to graph it on our calculator so we can find the intercepts, which you could totally do this by hand, but we're going to do it on the calculator. We have to make this equation say y equals. Does it say y equals?
No.
So what do we do? Okay. So now I have y squared equals 16, take away x squared. Does it say y squared?
No, you have to,
So if I am square rooting, I just put a square root in.
Is it a 16 or just 6?
It's a 16. I have messy handwriting. But I can tell. But I do have erasable pens. So, so when we square root, I heard someone say plus minus square root 16 minus x squared. Do not square root the 4 and the x. The 4. I mean, do not square the 16 and x squared to 4 and x. Do not do that. It's not correct.
How?
Oh, I'll show you. I'll show you.
Please.
I'll show you. Just go off on a tangent just for a moment. You guys from geometry, you did like a squared plus b squared equals c squared, the Pythagorean theorem. Whoever took geometry in here, do you remember one of the triples that always works and you're supposed to like memorize those
I
triples?
can remember that part.
5, 12,
After they start talking deeper about the Pythagorean theorem, I just started zoning out, to be honest.
Okay, but I just need,
still passed the
3, 4,
class.
5.
I need the easiest one, 3, 4, 5.
And then 5
So,
something.
yeah, I just need one. 3, 4, 5. If I did 3 squared plus 4 squared equals 5 squared, that should work every single time. What's 3 squared?
9,
9, 4 squared,
16,
and what's 5 squared?
27, 25.
Yeah, so those work. Those work. Now I'm going to show you why you cannot square root like this. This is wrong what I'm doing. This is wrong. Watch. If I did that, I will get 3 plus 4 equals 5. That is not true.
Oh, now I get it.
So you can't around that plus sign. You either square root the entire side or you don't square root at all. You can't square root the pieces. You have to square root the entire side. But in order to square root it, you have to first square numbers and add them together. So we can't square x and add it or subtract it with 16 because I don't know what x is. We cannot simplify that. This is what we're going to type in our calculator. What?
Also, that's it.
So now I'm just going to make positive 16 minus x squared, and y2 will be negative square root 16 minus x squared. We spent that time on it, and then there's going to be somebody who, I guarantee. I don't know when we get done with the chapter.
How many more sections we have left?
What are we on? 3, 4, 5, 6. 3.
We ain't having our chapter till like the end quarter.
Our chapters are long. We'll probably have another quiz before we have a chapter test. Okay. All right, so I'm typing in square root 16 minus x squared and negative square root 16 minus x squared. When we hit graph, it's going to look not very circular. It is a circle, I promise.
No, that's not.
It is a circle, I promise. But if you look at the screen, is the screen a square?
No. Yes. Wait, no, wait. Oh.
No, it's not.
In a rectangle.
It's a rectangle.
Oh.
So this is like taking that perfect circle and kind of like stretching it. That's why it looks like it's an oval. It's not.
Yeah.
A teeny tiny bit, I see what you're saying. But like it stretches it. Zoom. Martin, zoom.
6.
No. Square is 5. Zoom square is 5. And now it should be circular. Zoom.
Okay, now
5.
it looks like a circle.
There's something else.
Outside it, but it'll do.
There's something else that bothers people. It's the fact that your calculator doesn't connect it. I promise it is connected. It just
So,
show it, yeah. But I promise it is connected. So the last part of this question is where are the vertices? So not vertices, I'm sorry. Intercepts. It says where are the intercepts. So what do we have? What? That is not an intercept, or that might be an intercept. I need an order pair. Okay, so we've got negative 4, 0. There's one of them.
And 4, 0.
Positive 4, 0. These are the x-intercepts. Where are the y's?
4 is, no, 0, 4, and then negative. No, 0, and then.
0, 4, and then 0, negative 4.
Right? So those would be all the intercepts. So those are the questions that you'd answer about the circle. So just one more of these examples. Use your graphing calculator to graph. It says negative 4y squared equals x plus 1. So if I have negative 4y squared equals x plus 1, how do I get y by itself? What do I do
Divide
first?
4 to both sides. Negative 4.
Okay, I'm going to divide negative 4 to both sides. As soon as I divide by negative 4, if you are following simplify rules, something should bother you, because we have a negative in the denominator, and I know I'm not allowed to leave it there. But when you're graphing it, it doesn't matter. It doesn't matter that I'm leaving a negative down there, okay? Simplify, it would matter. The directions are just graph it and give me some information, so I'm going to leave that negative down there. What else do I need to do? Square root. Okay, as soon as I square root and put plus minus in, I now have a square root in a denominator. I have a radical in my denominator, which I also can't have. But for graphing, it doesn't matter. Okay, so even though this is not how you simplify it. What, hun?
4 negative.
Yeah, I was trying to fix it. It's messy. No, it's messy. Okay, so we're going to do y1 equals, we'll just do a big square root, x plus 1 over negative 4, and then y2 equals negative, big square root, x plus 1 over negative 4. I'm sure I've gone over this before, but I'm going to go over it again. There, you can put it as fractions. So if you have the new calculators, once you have your square root symbol, then do alpha equals enter, and it will give you that top and bottom. If you do not have the new calculators, I'll write down how to type it in. If you do not have the new calculator, you need to type it in. Then you do not have the new calculator. So you'll have to type it in like this, divided by negative 4, and just make sure that that is all underneath. Yeah, that's what you need. X plus 1 over negative 4. Square root, negative square root, alpha y equals x plus 1 over negative 4. It's a skinny one. Well, and also, I'm not on Zoom 6 either. Zoom 6. Still skinny. Which direction does it open?
Left.
Okay. And where's the vertex?
0, negative 1. Wait, sorry, negative 1.
Now, the reason why it's at negative 1, 0 is because we have an x plus 1, which means translate to the left 1. So I can get this stuff by looking at it. This one is a horizontal stretch and a reflection in the y-axis.
And do we have to write that down?
No, I'm just saying it. I'm not going to do the last one. It's another circle. It's exactly the same as the first circle, but 25. If it's dividing, that's the same thing as multiplying by 1/4.
So it's horizontal if it's a reaction.
It's horizontal if it's under the radical. Vertical if it's outside the radical. It is a stretch if it's division. Okay? All right, the assignment just gets added on to the one that you guys were already working on. I have it on Canvas, which I'm pulling up right now, but it's on Wednesday's Canvas.
What was the vertex 0, negative 4? 0,
A negative 1, 0. And so whatever I had on there before, I just like I ended it at 39. That's the part you should have been able to do through today. Yeah. Through 39 is the part you should have been able to do through today, and then the stuff you were adding on for Monday is after that. That was all together when you saw it last. I put that, this part will be due on Monday. I put that up last night. So it is the exact same thing that if you've already written it all down.